Hi, welcome to my talk on antipatterns in Python. A big part of developing a product revolves around designing it, but you can still have good design and end up with a horrible product. The breakpoints in your code that make it bad are always trivial and tiny, but they have cascading effect on longer run. So let's have a look at them. Let's discuss what is antipattern. An antipattern is an idea of how not to solve problem because implementing that idea would result in bad design. For example, a pattern would be to use a function for code reuse. An antipattern would be to use copy paste for the same. Now, a large part of day-to-day life of senior developer work involve code review of others. They are responsible for high code quality and affluent design. Hence, code reviews are rigorous and thorough. Let's look at few categories under which we can make sure that code reviews have covered them and there are no more anti-patterns in them. So, the categories that we will discuss are correctness. These are the anti-patterns that can break your code or make them buggy in production. Then we have maintainability, the anti-patterns that will make your code hard to maintain or extend. Then we have readability, the anti-patterns that will make your code hard to read or understand. And at last, performance, anti-patterns that will unnecessarily slow down your code and make them do things far more or make them less responsive. So the first category in correctness, we will see else clause on loop without a break statement. Let's have a look at this code snippet. The else clause for a loop is executed when the loop sequence is empty. When a loop specifies no break statement, the else clause will always execute because the loop sequence will eventually always become empty. Sometimes this is the intended behavior. In other cases, you should look into the code and review it if that is not desirable. Next one is assigning a lambda expression to a variable. Now, the sole advantage of having lambda expression over a definition is that lambda can be anonymously embedded within a larger expression. If you are going to assign a name to lambda, you better use definition. The first form means the name of resulting object or the resulting function object is specifically f instead of generic lambda. This is more useful for tracebacks and string representation in general. The next is assigning the built-in function. What happens that Python have number of built-in functions that are always accessible in interpreter. Unless you have a specific reason, you should neither override these functions nor assign a value to variable that has the same name as built-in function. Overwriting a built-in might have undesired side effects or can cause runtime errors. We should always stay clear of such scenarios. Next is not using the set default when initializing a dictionary. When initializing a dictionary, it is common to see a code check for the existence of a key and then create the key if it doesn't exist. Although there is nothing wrong with it, same idea can be accomplished more concisely by using the built-in dictionary method of set default. Now let's look at an anti-pattern which is very evil for us, because although there are many ways you can make your code do wrong things, but this one actually is responsible for hiding your production bugs, and that is no exception type specified. Look at the code snippet here. The function divides simply a by b. To avoid invalid calculation, a try except block is added. This is valid and ensures that the function always returns a result. However, by securing your code with try clause, we are actually hiding the programming errors that can raise the value errors by passing an object or a string in A or B instead of number. By not specifying an exception type, we are hiding the error and also losing the information about it. This can lead to the production bugs, which will continue to stay in production for a very long time and will be undetectable during the debugging as well, unless you put some solution of this. What we can do in this case to improve the try except, we can have the exact exception and based on their actual exception type. The first exception type that matches the current error is handled first. Hence, it is recommended to handle specific exception type first and generic error types towards the end of try except block. A useful thing here is the else clause because it gets executed only if no exception occur. It is useful to log the success of your code. The finally block executed under all the circumstances, no matter if an error occurred or not. It is useful to clean up the try except block. Along with Python standard exceptions, you can implement your own exception classes so that you can handle a particular case which is not easily or a particular situation where the raised exception is not helpful. Now the next one is mutable default value as an argument. Passing mutable list or dictionaries as default argument to a function can have unforeseen consequences. Usually when a programmer uses a list or dictionary as default argument to function, the programmer wants the program to create a new list or dictionary every time that function is called. However, this is not what Python does. The first time that function is called, Python creates a persistent object for the list or dictionary. Every subsequent time the function is called, Python uses the same persistent object that was created from the first call function. Hence, it will not perform as we expect it to do. So, the solution is to use a centil value to denote an empty list or dictionary. For example, in this one, it's none. Now the next one is maintainability. A program is maintainable if it is easy to understand and easy to modify the code even for someone that is unfamiliar with the code base. Hence, we should avoid antipatterns, specifically the antipatterns that result in spaghetti code. The first issue that arises during maintaining a code base is when a function returns more than one variable type. Look at the code here. If a function that is supposed to return a given type and suddenly returns something else, the caller of that function will always need to check the type of return value before proceeding. This results in confusing and complex code. So what we can do? We should always raise an exception if function is unable to produce the supposed return value, like this. So the caller has to just wrap the function call into try except and handle the exact error that is being raised. Next is dynamically creating variable, method, and function names. Now sometimes a programmer gets an idea to make his or her work easy by creating magically working code that use getter and setter functions to set some variables. While this may look like a good idea, because there is no need to write all the method by hands. But this can create issue down the road. So here, let's say that you have a data dictionary. During the initialization, you pass through that data dictionary and use this getter and setter to set the variables. Now consider this code snippet. Now the class contains another unknown variables indexed by their count. Now this looks like okay for now, but it will look like a mess after a year when you were trying to find out where these variables come from. While the approach in the example above may be easier to write, but it is very difficult to maintain later. We should always try to find another way to solve this problem. The typical approach that can solve this problem is to use function to parse your incoming data, or use the data dictionary itself without class. This, however, depends on the task at hand. Next, readability. This is very important code review category, because even if your code works as fluent as it should and it is easy to maintain, but if it is difficult to read it, the reviewer is going to be very angry, because if your code is not readable and tomorrow if you hand over your work to somebody else, their life will become hell. That is something we don't want to do. So our priority should be writing clean and readable code that works first, using known and testable algorithms and tools. The anti-patterns that contribute in making your code less readable: first is not using the dictionary keys when formatting. Now, suppose you have a dictionary and you have to generate a string based on that dictionary keys. If the number of items in your dictionary is very less, it's fine. You know which index will be mapped to which dictionary key value. But suppose you have 15 keys in your dictionary and you have to generate a single string using all the fields in your dictionary. That will be a problem if you mess up a single field, because that changed the meaning of your string. What we can do in this case is use the dictionary itself and use the dictionary key instead of index to put the value in the string. It is more cleaner and readable, and the person who is reviewing your code will know that which key you are trying to put there. They don't have to go back and forth in format section and the key indexing. Next is comparing things to true in wrong way. Now, the purpose of PEP 8 style guide is to improve the readability of code. Now, for sure, it is an anti-pattern, the one that we are going to discuss, not only in Python but in almost every programming language. You have a boolean, you are trying to figure out its value. If it is true, you go ahead. If it is not true, you will do something else. Now, if you just compare it with the true literal itself, this will work, but that is not a desirable or preferred PEP 8 style. If you directly use it as if the flag, then yes, this is something which is widely acceptable and known as one of the best approaches. Unless if you want to distinguish between non-empty list and true itself, always choose the second option. If flag is true should only be useful when you are trying to figure out if flag is actually boolean true or flag contains some other thing. Flag can be 1, flag can be a non-empty list, flag can be anything which doesn't represent false or 0. So in that case, you have to actually use if flag is true. In any other case, just go with if flag. The next one is not using zip to iterate over pair of list. Now this is an antipattern which is always very handy when you are having more than one list. So whenever you have a list, we loop through, we first calculate the length of one of the list and then use the range to go through the index and iterate over them. But the preferred way to iterate through a pair of lists is to declare two variables in a loop expression and then call zip on those two lists, so that for loop for each loop iteration, Python will automatically assign the first variable and second variable as the items for first list and the second list. Python takes care of that, and you don't have to worry about doing that on your own. Now, not using the name tuples. This is something which I figured out is very handy approach, and it helps you to understand the other's code more. Suppose you have a code that return a first name, middle name, and last name using a normal unnamed tuple. After calling the tuple, each value can only be returned by an index. This code is difficult to use because the caller of function has to know first element is the first name, second is the middle name, third is the last name. What can be done instead of this is using the name tuple. Now, name tuple can return multiple values. They can be used anywhere where normal tuples are acceptable, but their values can be accessible through their names in addition to their indexes. This makes the code more verbose and readable. Now, everything in your code is working, everything is fine, it's readable, it's maintainable, it's doing it's correct syntactically and semantically, but if the main contributing factor is performance, if it is slow, it will raise the eyebrows. Your code should perform certain tasks within a certain limit of time, certain acceptable limit of time. If it takes more than that, then it will be a question on the code itself. Let's have a look into the code cases which impact the performance of your code. Large performance gains can be obtained by using appropriate functions and directives. The first one is, let's say that you have a list of items and there is a code snippet which checks whether an item exists in the list or not. For this, the simple approach is iterate over each element, compare it with the element we want to see or we want to find out, and handle it in if-else loop. For small list, this looks fine, and this is okay because improving this particular code for a list of 10 will not have any performance impact. But let's say that if you have a list of a million or 100k elements, then it is always advisable to use set. The working or the result is same as you're iterating through list. If it is there, it will tell you. If it is not there, it will tell you. But in both cases, the turnaround time of searching through set is always constant, and we want to exploit that particular feature of set to improve our performance and reduce our turnaround time. Next is not using literal syntax to initialize empty. Now, this is something which we have seen a couple of times. It is relatively slower to initialize an empty list by calling list than using the empty literal, like this. Why the latter is preferred? Because the name list must be looked up in the global scope in case it has been rebound, or maybe we have user-defined function with the name list itself and we want to initialize our variable with that. But if you define a literal, Python will know that you are explicitly mentioning that you want the list only, the built-in list only, not something else. I mean, we want to make sure that Python doesn't spend time in looking into the scope. Premature optimization. This is something we all do knowingly, unknowingly. What happens that we optimize for performance before even setting up an effective architecture. This results in lower code readability. It becomes more difficult to debug it, let alone maintain it. Maintaining the code which is highly optimized prematurely, it's very hard to maintain that. And it adds superfluous parts to our code which we may do not need. So how we can handle premature optimization? First, make sure that you have a working code, clean, clear, understandable, and following all the other standards. Then you profile it. You test it. Once you are done with that, profiling will help you in figuring out the points that you should optimize. It will highlight your bottlenecks. Once your bottlenecks are highlighted, then you optimize it. If you optimize beforehand, you may end up optimizing the wrong part of your code. And along with that, to prevent premature optimization, it is as advisable to create the things when you need them. This is something called YAGNI. You are not gonna get it programming principle. It's a very generic programming principle, but it advises that always implement things when you actually need them, never when you just foresee that you need them. Maybe you will think that you need certain parameter, or you may need to add certain field in your response payload, but if the end user don't need it right now, then don't add it. When you have actual user requesting for that field, or you have a reason to add it over there, which if you're going to use it immediately, then only add it. Else, don't add it. You will only increase the turnaround time and the payload size, nothing else. In the conclusion, these are the points which helped me in improving my coding style. Don't do it is a bit high talk, but yes, we can always improve our coding by using these points or keeping these points in our mind, because they improve our code and make them more readable and maintainable, which is the target goal at most of the questions we have. Now, this particular link has been very helpful to me because it has summarized not only the anti-patterns that I have learned, but many anti-patterns beyond that. So you can always refer to this link, and you can always learn new anti-patterns, not only the one that I've discussed, but the ones which I have not discussed as well. Thank you. Happy coding. I hope you have enjoyed my talk. If you have any questions, you can reach out to me on LinkedIn or Twitter. Thank you.
So we move to the question section. So we don't have questions. We only have suggestions that regarding the set example. And there's a comment from Lydia. Thank you for very useful talk. So I don't see questions. There is a question. Shouldn't we use, and it's in the brackets 1, 2, 3 instead of, I'm sending you the question so you can see it. It's on the Discord. So it's a suggestion. There's also a question. Can you share the anti-pattern link?
Sure. I will.
Okay.
I will send the PPT slide and the PDF that is going to be shared with everyone. And I'll where can I share it, Philip? Please let me know.
On Discord. Please share all the materials you have on Discord.
Okay, thank you. Thank you everyone who has joined this talk. Please let me know if you have any other question. I think the one that Philip was asking, that was about the suggestion of either using the literal curly bracket or the set name itself. So yeah, I get the concept you are trying to say. I was just trying to be more explicit in what needs to be done. But thank
Okay.
you.
Okay. Thank you, Pratibha and Pratibha, and see you later on Discord.